Hello guys, we'll be solving a new very interesting and new equation I found quite recently. So the equation states that for how many triplet solutions are there given these are the given constraints. Let me write these down. So x, z, and y must be elements of natural numbers, so like 1, 2, 3, 4, 5, just stretching out to infinity. Natural numbers do not include 0. I've got to make that very clear. Furthermore, z being the biggest number is bigger or equal to y, and y is bigger or equal to x. Okay, and last piece of information we get is y plus x plus z equals 10. Okay, immediately we can know that the maximum number that we can have as a possible solution, the maximum number, the range of numbers is that we can have for this system is 1 to 10. Okay. In actuality, 10 and 9 must be crossed out because if, let's say, z was equal to 10, it would leave y and x equaling 0, which can't happen because remember 0 is not part of the natural number set. The same thing with 9, only with the given change that only one of the variables now equals 0, but that's still not allowed, so we have to cross it out. Okay, so now we have 8, 7, 6, 5, 4, 3, 2, and 1. Okay, let's try writing them out like this. Let's play around with this to see if we can find a solution. Okay. Imagine these little lines are drawn as placeholders, okay? And z being the biggest number, let's try out 8. So if 8 is the biggest number, 8 minus 10 equals 2. And that means that these numbers right here, y plus x, must arrange themselves in some way from 1 to be able to equal 2. So the only solution to this is 1 and 1 because y can be equal to x. So therefore we can write a solution as 1, 1. Okay, so we have first solution, 8, 1, 1. We cross it out because you can't have another solution because you can only split 2 into 1 and 1. Now we try 7. So try again, 10 minus 7 equals 3. Ooh, this one's a little bit more interesting now. So for this, you can have 2 and 1, and that's pretty much it, yeah. So then you can have 2 and 1. And now we try again for 6. So we put 6 here, and then we go, okay, 4 can be split into 3 and 1, and it can also be split into 2 and 2. So we write 6 as just that, and then we write 631. So now we have 4 solutions now, and we've cleared out 8, 7, and 6. Let's keep on going. Let's try 5. So we just go 10 minus 5 equals 5. So we put 5 here. And 5 can be written as 3 and 2 and 4 and 1. So 4 and 1 and 3 and 2. Okay, so now we have 1, 2, 3, 4, 5, 6 solutions to this equation. Okay. Now we have to try 4. So we get 10, we minus it by 4, and we get 6. Now it might look a little bit strange now, but trust me, it does work. Let me just clear out some space here. So now you can get 4 as a z, and you get 6 here, which can be split into 3, 3, and 4 and 2. Okay, so you can write 3 and 3 here because y and x are equal to each other, and you can write 4, 4, and 2 because z and y can be equal to each other, and y has to be bigger than x. Okay. Now you have all your 8 solutions. 1, 2, 3, 4, 5, 6, 7, 8. The reason you can only have these 8 solutions is because let's say we keep on going and go 10 minus 3. So if we have 10 minus 3, that gives us 7, which can be split into 4 and 3. If it's split into 4 and 3, if we put 3 here, let's say we put 3 here, and we put, let's say, like 4 here and 3 here, that this fact right here violates one of the constraints because you're essentially saying that y is bigger than z when it can't be, because z always must be bigger than y or equal to. So then this is an invalid solution, and hence, given that z cannot equal 3, any number past this becomes invalid as well. So therefore, the only solutions you can have right here, giving you a total of 8 solutions, which is a pretty cool number. It's actually a pretty special number to me. Anyway, I hope you guys enjoyed watching. Bye.